Hi everyone, welcome to lecture 30 of your electric circuit class. And lecture 30 is about RMS values. So the objectives of this lecture, the first objective is to know what RMS term stands for. The second objective is to calculate the RMS value for any periodic waveform. And the third objective is to know the average power in terms of RMS voltage and current. So RMS value so we can say that the RMS, which stands for root mean square value, is the effective value of time varying waveform. So the RMS value of any periodic function and let's say that the function is x of t, and of course that if we have a voltage that will be v of t, if we have a current that is I of t, is generally given by this equation here. X RMS is equal to the square root of 1 over the period t multiplied by the integral goes from 0 to the period t of the function squared, that is x squared dt. So this is our XRMS value. So the RMS value of any given periodic function can be determined through this equation. So the RMS values in sine wave, so the RMS values of voltage and current in AC circuits are given by VRMS is equal to Vm divided by radical of 2, which means that our Vm is equal to radical of 2 times VRMS. and our IRMS is equal to IM divided by radical of 2, which means that our IM is equal radical of 2 IRMS. And of course that will be applicable to even phasors. That is the same thing. So from where we get this, let's say Vm over radical of 2, if we apply this equation, which is the XRMS, to a given sinusoidal waveform, we will end up with the maximum value, which is, for example, Vm divided by radical of 2. I would like everybody to know that all voltmeters and ammeters display RMS reading of voltages and currents. So if you bring, let's say, a voltmeter and you measure a voltage across an element in AC, that value that will show for you the voltage reading, that is RMS value. Same thing that is applicable to the reading of the current. So now, what about the average power? So we remember that average power is equal to 1/2 Vm Im cosine of theta V minus theta I. That is the formula for average power when we are using, let's say, sinusoidal waveforms. And now, in terms of RMS values, so we will just substitute Vm, that is radical of 2 VRMS, and Im, that is radical of 2 IRMS cosine of theta V minus theta I. So if you look at this here, radical of 2 times radical of 2, that is 2. So 1/2 times 2 VRMS IRMS cosine of theta V minus theta I. So this 2 will cancel with that 2, then we will end up with VRMS IRMS cosine of theta V minus theta I. And that is in watts. So in terms of RMS values, if you can see that the half disappeared, and then we will have VRMS IRMS cosine theta V minus theta I. So if you would like to find, let's say, the average power of any given element, if we know the RMS value across it and the RMS current flowing through it, then we will be able to find the or determine the average power. So let us go over an example to find an RMS value for a given waveform. So we would like to find the RMS current for the waveform shown here. And this is our waveform. That is T, and this is I of T. This is 0, that is 2, 3, 4, 6, and 7. So this is our periodic waveform. So to get the RMS value, this is what we are gonna do. So since the question is about current, then IRMS. So we need the RMS value of the current. That is equal to square root of 1 over t, the integral from 0 to t of I squared dt. So usually students that they have a mistake when they do this. Sometimes whether they forget to put the square root over here, or they forget the square for the function. So don't do that. So now if you look at this here, at this formula, first thing that we need to determine our period t. So what is t in this case? If you look at, so time here is given in seconds. If you look at this waveform, the period t, it is the time where the function gonna repeat itself. So in this case is equal to 4, because at this point here it will repeat itself. So our t is equal to 4 seconds. So now we need to find our current. So I of t is equal to, the first one, if you look at that, the value here is 2 in ampere. So from 0 to 2, we have the function is equal to 2. So that is t greater than 0 and less than 2. Then from t greater than 2 and less than 3, it is this line here. And that line is negative 2t plus 6. And then from t between 3, let's say, and 4, that is 0. So this is the function of our current. So we do have that waveform to be 2 between 0 and 2. Then there is a slope going down, that is negative 2t plus 6. And then we have from 3 to 4, it is 0. So now we can say our IRMS is equal to square root of 1 over t, that is 1 over 4, multiplied by the integral 0 to 2, because this is 0 to 2, and that is 2 squared dt, plus the integral from 2 to 3, which is for this, that is negative 2t plus 6 squared dt, then plus the integral from 3 to 4 is 0 squared dt. So this is our function for the whole period. So if you look over here, we started at 0 and we ended with 4. That is a whole period. So now that is equal to square root of 1 over 4. Now our 2 squared, that is 4, right? So we can say from 0 to 2 of 4 dt plus 2 to 3 of 4 t squared minus 24t plus 36 dt. And of course that this term, since it is 0, we don't care about it. So that is equal to. So now this term here, that is really negative 2t plus 6 squared, which is negative 2t plus 6, the whole quantity multiplied by negative 2t plus 6. So that is the square root of 1 over 4. Now the integral of 4 dt is 4t, and that goes from 0 to 2, plus the integral of 4t squared minus 24t plus 36, that is 4t cubed over 3, minus 24t squared over 2 plus 36t, and that goes from 2 to 3. So that is equal to the square root of 1 over 4 multiplied by 9.33, and this is equal to 1.53 ampere. So in this here 4t, that is 4 times 2 minus 4t minus 0. I mean 4, let me repeat that. 4t here is 4 times 2 minus 4 times 0. This over here 4t cubed over 3, the same thing that you have to substitute the 3 and the 2, right? You know how to do your integration and substitution. Here is another example. Find the RMS value of a voltage given as V of t is equal to 100 cosine omega t plus 30 degrees. That is in volts. If you look at this here, that is in time domain. So in phasor domain, that is equal to 100 with angle 30 degrees volts. So if you look at that, this value here is Vm, right? So our V RMS is equal to Vm over radical of 2, and that is with angle 30 degrees. And in this case, 100 divided by radical of 2 with angle 30 degrees, this is equal to 70.71 with angle 30 degrees. From that, our VRMS is equal to 70.71 volt. So this is here is a phasor quantity with a phase angle. This is the magnitude of our RMS value. Here is another example. Suppose that we need to determine the average power absorbed by the 2 ohm resistor. And our circuit like this. This is a 20 with angle 0 volt. This is 2, and that is J2. And this is over here, let's say, excuse me, this is where we need to find our average power absorbed by the 2 ohm, because as you know that the J2 will not absorb average power at all, right? Because the angle difference between the voltage across it and the current flowing through it is exactly 90 degrees, and cosine of 90 degrees is 0. Then the whole term for average power will be 0. So I would like you, excuse me, I would like you to pay attention from now on to look at the given values, whether a voltage or a current. If this is given as a 20 with angle 0 volts, that means we are using Vm with angle theta V, let's say. Clear? However, if we are given the value as, let's say, 20 with angle 0 volts RMS, then we will know that this is RMS value. Okay, so in this case over here, our 20 with angle 0, it is the maximum value, it is not RMS. So now, to find the average power absorbed by this 2 ohm resistor, if I know the voltage across it or the current through it, we will be able to solve for that average power. So let us go with finding the current. So this is our I. So our I here, since we have only a single loop, that will be the voltage divided by the total impedance, which is 2 plus J2. And in this case, that is equal to 5 minus J5, and that is equal to, of course, that is in ampere. So now if we convert that to polar form, that will be 7.071 with angle negative 45 degrees, and that is in ampere. So now we can find our average power as 1/2 Im squared times R, because we know now the current flowing through that ohm resistor. And this is equal to 1/2, and our Im is this, which is 7.071 squared, and R is 2. And the answer here is 50 watts. Or we can use RMS values. So our IRMS is equal to I divided by radical of 2, which is equal to 7.071 with angle negative 45 degrees divided by radical of 2, and that is equal to 5 with angle negative 45 degrees, and that is in ampere. So in this case, our P is equal to I RMS squared times R, because the value of the current now is in RMS. So RMS, that is 5 squared times 2, which is 25 times 2, that is 50 watts. So if you look at that, that is 50 watts. It's exactly the same as this 50 watts. Or we can use voltage division for this problem here. As long as I know the voltage across the 2 ohm resistor, then we can find the average power. So in this case, if I have the voltage over here, we call it phasor V, then our V is equal to 2 divided by 2 plus J2 multiplied by 20 with angle 0. And when we do that, that is 10 minus J10 volts, which is equal to 14.14 with angle negative 45 degrees. That is in volt. So now we know the voltage drop across that 2 ohm resistor. So our average power P is equal to 1/2 Vm squared over R. And in this case, 1/2 Vm is 14.14 squared over 2. And when you do that, that will be 50 watts. And that is the same as what we got earlier. In RMS, if we have the values available, our VRMS is equal to V over radical of 2, and that is 14.14 with angle negative 45 degrees divided by radical of 2, and that is equal to 10 with angle negative 45 degrees in volts. So now our P is equal to VRMS squared divided by R, and that is 10 squared divided by 2. So 100 divided by 2, that is 50 watts, which is the same as what we got before. Or we can use P is equal to VRMS IRMS cosine of theta V minus theta I, and that is equal to, our VRMS value is 10, our IRMS value is 5, and then cosine of negative 45 degrees minus negative 45 degrees. Because resistor, as you know, since it is a resistor, we have the voltage and the current in phase, which means that the angle of the voltage and the angle of the current are equal. That's why both of them are negative 45 degrees in this case, which means that this here is really 0. So now cosine 0 is what? Cosine 0 is 1, and 10 times 5 is 50. So that is 50 watts. So any way over here that you can use, that is not a problem. So you will reach the same answer. For this lecture, as long as you know what we meant by RMS value, which is also written as RMS, you will be great. And we said that for any function, xRMS is equal to 1 over t, the integral from 0 to t of x squared dt. And make sure that our period over here, it can be determined where the function gonna repeat itself. So for example, if I have this function over here, this is 0, this is 1, 2, 3, and 4. So if you look at this function, it's going to repeat itself over here. That means this is our period t. If I have a function like this, this is 0, 1, 2, 3. So if you look at this here, this point over here where the function gonna repeat itself, so that means this is our t. What about if we have a function like this? This is 0, this is 1, 2, 3. So if you look at this, the function or the waveform is gonna repeat itself at this point. That means this is our t. Okay. All right. And then we said that our VRMS value is equal to Vm divided by radical of 2. Our IRMS value is equal to Im over radical of 2. This is for what? Sinusoidal waveforms. All right, so this is our homework for this lecture. It it is only like 3 problems, and I think that they are doable in reasonable time. Thank you for watching.